Alright guys, so in this video we're continuing our vector fun as we continue to kind of just open up into the topic. So the goals of this video are to look into what a direction angle is, negative vectors, how to label vectors, and then we're also going to look at a head minus tail rule to start finding some magnitude as well. And so let's first and foremost talk about a direction angle. The definition, I'll be real with you, I mean the definition I have on here probably makes it sound worse than it is, but it is kind of interesting to at least kind of understand where it comes from. The direction angle is just simply the smallest non-negative angle created by the standard position and the standard representation for the terminal ray. Okay, and so I mean all this really, guys, kind of just shows here, we've kind of only looked at it in the past as well too, but let's say for instance that we're dealing with a vector and we're going to be at 1, 2, 3, 1, 2, 3, and 4. Let's go ahead and say that we're at a vector here at point 3, comma 4. And here we go. Here is our vector. We're going to call this, I guess, O for the origin down in here. And so let's go ahead and think about what this actually means. The angle right in here, our angle formed right here, that's theta. That's our direction angle that we're talking about, okay? And so x-axis will be the initial ray, and then we're looking at the terminal ray being the vector from vector OP in this case. And so we would go ahead and identify this particular vector as vector OP just as such, all right? And so this is vector OP, and the vector in component form is 3, 4. Because basically what this tells us, guys, is that I moved 3 positions to the right and 4 units up. But what I want to show also is that I could have a additional vector in which we got 1, 2, 3, and 4. And then let's say we're up here at 6, so they extended out a little bit. And if I went ahead and said, hey, what about the point negative 4, 2? So here's negative 4, comma, negative 2. And then at negative 1, positive 6 up here. So negative 1, positive 6. And I created that vector there as well. We'll call this Q and we'll call this R up here. And so we now have vector QR into the mix as well. And the point of this part is, guys, just to kind of understand that both vectors are the same component form. Vector QR, whoops, not 3R, 3, 4, all right, is also going to be 3, 4. To get from the initial point Q, I had to go over 3 units, right? 1, 2, and 3. I had to go over 3 units and up 4 units to get to my R. And so that's why the component form in that case is 3, 4 as well. So since these are the same magnitude for our vectors, all right, we would call them equivalent vectors there. And they're also parallel vectors as well. All right, and so the next thing we're going to kind of dive on into is we've started talking about direction angles, and then now the next thing we're going to go into is specifically about head minus tail rule, and we're going to start actually finding, I guess, some magnitude that we are dealing with now. So let's go ahead and take a look at what our head minus tail rule is going to be. So let's just think for a sec. You know, if an arrow has an initial point, we're going to call it x1. And so if an arrow has an initial point, we're going to call that x1, y1. All right, so x1, y1. And we'll call its terminal point and has a terminal point. We're going to call that x2, y2. All right, x2, y2. We can represent it in component form as the difference between x1 and x2, comma, the difference between y2 and y1. That's exactly what we represented in our diagram. How many to the right or to the left to get to the next x value, how many up or how many down to get to the next y value there. All right, and so the first example that I want to go ahead and look at with this concept here is to find the magnitude and the direction angle, call it theta, of the vector. And sometimes we're talking about vectors, guys. We'll put, if we're not going to bold it, we'll kind of put a line underneath it as well, too. Of the vector of -1 root 3. And, yep, that's it right there. All right. So, of the vector at -1 root 3. All right. So, let's first kind of take a look at, I guess, what the possibilities are here. Let's kind of just draw this for fun. All right. So, a little bit of fun here. Let's just draw it. So at -1 and then kind of somewhere right before 2 at root 3. So somewhere in here we'll be at the point -1 root 3. And as of right now, guys, I know that it was given it to us in component form, but that's all I have to really go by. That I had to go to the left one and I had to go up root 3. So my best guess is just to use the origin as my starting point for it all. Okay. So the magnitude, remember guys, the magnitude is the absolute value of V, or I could have just written that underline in there as well too. And so we want to go ahead and find out what the distance is from those particular spots, right? Well, remember our distance formula, guys, the root of, in our case, we're going to be ending up at -1 minus 0 squared plus root 3 minus 0 squared. So the size of this vector. All right, so to find this out, this becomes 1, 3, so root 4, and so root 4 is going to be 2. So the size of this vector is going to be 2. All right, well, so the size of the vector is going to end up being 2. How can we go about finding our actual direction angle? Well, let's kind of remember for a second. Let me change colors here. So our direction angle is our starting point, our initial side, the x-axis, and our terminal side is going to end up being our vector. So we want to find out what that angle theta is going to be. And this has a value of, not root 2, but 2 now. All right, so it's a value of 2 that we're dealing with. Okay, so let's think here for a sec. If my if my x-coordinates, remember the x-coordinates, guys? The x-coordinates represent your cosine functions, and your y-coordinates represent your y functions. So let's say, for instance, I kind of think about this vector now as a right triangle being formed. We got to kind of think to ourselves now in terms of cosine and sine, kind of what is this point here at -1, 3. All right. Well, we're going to kind of think, and I guess I should probably erase this now. We'll quickly kind of put this on the outside, because remember our vector has a length of 2. Our vector had a length of 2, so I'll put that over there. And so really the vector represents the hypotenuse of it. So remember, guys, cosine of theta is going to end up being your x over r, right? Where r is going to be that hypotenuse. And then your sine of theta is going to end up being your y over r. And so in this case, cosine of theta would end up being -1 over 2. And sine of theta ended up being root 3 over 2. And so then now we got to ask ourselves, where on the unit circle do we know that there is an angle in which cosine is -1/2 and sine is square root 3 over 2? And hopefully remember that on our unit circle that happens at 2 pi thirds. So theta will equal 2 pi over 3. Or if we're looking at terms of our degrees, that's going to be at 120 degrees. All right, so utilizing our vector information to kind of put it into perspective about our angles. All right, so the last thing I kind of want to talk about here in this video is the concept of negative vectors. All right, the concept of negative vectors here. So where does it come from? How does it work? All right, well, let's kind of think here for a sec. Let's just say, for instance, I'll use PQ again. Let's say I have the vector PQ. So I have the vector PQ here. And let's say it has a length of A. Let's say it has a length of A right in there. If I wanted to say, hey, well, what is the length? What's the length of vector QP, right? If this is vector PQ, right, what's the length of vector QP? Well, the expression, yes, it will be the same, all right, but the vector itself for QP would end up now giving us a negative A, right? So if PQ was A, then QP would be considered negative A, because it's just the negative vector or of PQ, or the opposite vector of PQ. All right. So if you kind of think about it in a sense, they have the same length, but there's opposite directions, right? And so in general, what we can make the statement would be is that, hey, if we have PQ, right, PQ will equal the opposite of QP. Okay, it'll be the opposite of QP. All right, guys, and that is going to wrap it up for our vector talk here. One, I do want you guys to give a shot on your own as we kind of continue our practice here on vectors. Is going to be working on finding the magnitude. So once again, I want you to find the magnitude and the direction angle. So find the magnitude and the direction angle. And in this case, we are going to be looking at what about the vector with component form negative root 2, positive root 2. All right, so find the magnitude and the direction of vector with component form of negative root 2, root 2. And we're on to the next one, folks.